Chapter 1 illustrates how capital, equity, and betas are valued and calculated. And this can be an involved process, but just like many of the other models we have looked at this semester, if you keep your process organized and consistent, it will be much easier to learn. Now in this video, we will look at weighted average cost of capital. And the weighted average cost of capital, or the WACC as it's usually called, is the cost of capital across the entire firm. From a practical standpoint, if you can calculate your weighted average grade or you can calculate mixtures, you'll be able to see that the calculation of the WACC is very similar. Again, if you keep your process organized and consistent, you will master this with little problem. In example 11.1, we have a very simplified example of how this calculation is performed. Excuse me, I'm not going to follow the workup of the WACC exactly the way they do in the book because the way I set up my WACC calculation is a little different, but the final answer will be the same and you'll be able to follow what I'm doing. Now, first of all, I list all the debt that will be included in the WACC. Now, in example 11.1, there are 3 sources of debt. I don't really care who the debt is from or who is holding the notes. All I care about is the amount and the interest rate. So we have $350 at 6%. We have $200 at 8%. And we have $250 at 12%. So I'll list all the debt in the first column. Now I know just from looking at the portfolio that the correct answer is going to fall somewhere between 6% and 12% because that's our lowest and our highest interest rate. So the weighted average can't be lower than 6 or higher than 12. And since more than half of the portfolio is at an interest rate at or greater than 8%, then I'm thinking that my weighted average cost of capital is probably going to be somewhere around 8 to 9%. So this is where I'm expecting the range of my answer to be. So if my final answer to WACC was lower than 8% or higher than 9%, I would not trust my answer and would probably look at it again. Now the next thing I do is I add up all the debt so that I have the total debt for the company. And in this example, that's $800. And now I can determine what percentage of the debt portfolio is being allocated to each loan. Now I do that by multiplying the amount of the loan or dividing the amount of the loan by the total of the debt being carried by the company. So that means in the next column, I'm taking 350, dividing it by 800, the total amount, and that gives me 0.43750. And then 200 divided by 800, and that gives me 0.25000. And then in the third line, 250 divided by 800, and that gives me 0.31250. Those decimals or those percentages indicate the weight of each loan. And the next thing I do is I multiply the weight of each loan by the interest rate. So here it is 0.06, and the next line is 0.08, and the next line is 0.12. And that gives me, when I take 0.43750 and multiply it by the interest rate, I get 0.026250. 0.026250, a little confusing there. Okay, then 0.25000 times 0.8 gives me 0.02. And then 0.31250 times 0.12, that gives me 0.037500. I add all of that together, I get 0.083750, or 8.37% interest. Now, when I look at my calculated answer, I see that my WACC came in at 8.37%, and my original guess was that it would be somewhere between 8 and 9%. So I'm happy with my answer. Now, example 8.11 immediately turns over into the weighted average cost of capital, and it gives you an example of how this is applied. So let's take a look at this real quick. Okay, now if you'll remember from the earlier chapter, the net present value equation is equal to the negative cash flow, which is the amount of money from the investment, and then the present value of each cash flow period. And this formula should look pretty familiar to you. Okay. Now, when you're dealing with net present value, the only rate that you should be using is the weighted average cost of capital. That is the proper discount rate to use when you are using net present value. So if we make that assumption, we would take the net present value, the negative $800, which is the original cash outlay that was being borrowed, and Stan predicted that in the first year he'd make $1,000. And then you would divide that by 1 plus the rate, and in this case the rate is the weighted average cost of capital, 1.0838 raised to the 1. Then when you calculate all that out, you get negative 800 plus 922.679461, and that is equal to 122.679461, and that is approximately $122.68. Now, since the net present value is greater than 0, Stan should move forward with this project.